So, in the previous video we were looking at Whiteson's non-blocking switch, and I had talked about the states and how to set up the equivalence between the states, and in fact I told that you can twist the outputs, you can twist the whole switch, you can twist the switch actually around. So, input becomes output and output becomes input, or you can actually do up and down. So, in any direction you can actually move the switch around, and they should you should be able to transform from other states to the one state, then the one to other state, then these two states will be equivalent states. And we in fact use that to compute the non-equivalent state for single connection and non-equivalent states for the two connections. So, let us draw those states which I had actually finished up with them in the previous video. So, these ones were the states. So, this was the first state which I had drawn, and remember what we are doing is we are trying to prove that this is a Whiteson's non-blocking switch. It does have a blocking state, but by using a suitable algorithm I will be able to operate this switch as if it is a strictly non-blocking switch. Okay. So, in true sense, strict sense non-blocking switches, they will not have any blocking state, but Whiteson's non-blocking switches will have blocking states, but by suitable operational algorithm you can avoid those blocking states. So, the remaining ones, they were actually like this. I will switch back to color diagrams when I will now do the third connection actually. So, these are essentially now the states with to which we actually have arrived in the previous video. Now, I have to set up the third connection. So, I will take one by one each one of these second stage two connection states, and then see if I set up the third connection what I will actually can convert them into. So, I have to essentially do again the equivalent transformation. So, we will do that. So, we will take up the first one. So, I will take up this one and then see what can happen. So, we will do it on the other side of the board. So, we will have this configuration. So, now let us draw the first diagram in with the for the two connection. So, this one will look something like this. So, the second connection which I had is this one, which corresponds to this particular connection. Now, let me see in how many possible ways I can set up the third connection. So, third connection obviously has to be from here to here. Okay. So, the way it can go is I will take all possible combinations. The first one is, as usual, I will always try to move upward first and then second step to the downward. So, if I actually go upward, it has to go downward. There is no other option, it has to go in this fashion. That is one possible state. So, let us look at the other possibilities. I have to also check the equivalence actually. Second possibility, this can actually go to downward. So, there is no possibility it has to go up and then straight and out. Now, you can actually see if I twist this switch around, they both are actually same. So, third configuration, if I do, these two are equivalent, there is only one third possibility which can exist, there is no other way. And this actually you will arrive if you are in this switch state. If the moment you set up the connection, you only come to this possibility. Okay, there is no other possibility which will exist. Okay. So, this is the third one. So, we can actually draw this state here. Okay. So, you can actually go from here to here and from here to here. Okay, that is what when I am doing it, I set up third connection whatever way I will always come to this particular state. Okay, there is only one state, there are two possibilities, but both of them are actually technically same. So, now let me see if what will happen if I take this state. So, I can actually reach from here to here. So, we have this connection already being done. So, now I can actually set up, take this input, I can connect to this one or I can connect to this one. So, let us see what will happen if I do this. Okay. So, I can go straight first, I can go to bottom, only way the connection can be made is in this fashion. Okay. Now, the way the equivalence has to be set up, that I would like both of these to be in the bottom side as far as possible, okay, and then see what is going to happen. So, let us do the transformation. So, I will always try that the two inputs or two outputs which are occupied, those switches are in the bottom. So, basically trying to find out the equivalence with this. So, everywhere else there is only bottom, we have only two. Only one of the inputs where the two of both the inputs are occupied, then the outputs are from the two separate switches. In this case the outputs are from always both separate inputs state switches and both output state switches. So, this actually means I have to do the transformation in this fashion, and then I need a straight line, so that this straight line actually comes in. So, I will take this pink one and make it into a straight line, which actually implies I have to do this swap, I have to do this swap, and let us see what will turn out. Okay. So, we will have from here I can now draw the pink straight. Okay. So, the white ones. So, what happens to the white path? So, white path will become goes from up and straight, okay. And of course, now what happens to the yellow one? The yellow one is going down, going up, okay, and then going down and coming here. So, this is a standard configuration which we have. So, usually one of the states. So, this gets transformed to this one. Okay. Now, second possibility which can exist is this. So, I had set up the earlier the yellow line while going towards the top and then coming to bottom and connecting. This time I will go to the bottom. Oh, I ended up in the same thing. So, these are the only two possibilities which exist. There is no other option which is available. They both are technically same, okay, except this pink and white gets changed, but they are technically same states. There is only one possible state in which this switch actually can go. So, let me draw that also. Okay, so you will come from here to here. So, next we have to look into this particular configuration and see what all possibilities will exist. So, I will again try to go straight first. I cannot go to the bottom, I go straight first. I can still can go straight first, that is one possibility. But to be on the standard side, when I am actually making this 3 connection thing, I am always trying to put 2 connections coming from the in the bottom switch on both sides, input and output. So, this one will be now here. So, I have to now do this swap. Once I do this swap, I still need a straight line all the way in the bottom. So, a straight line can only come if I take, if I do not do this swap, but I do this particular swap. These two things has to be swapped and then I will get a straight line in the bottom and both 2 inputs and outputs on the bottom side. Let us see what will happen. So, important thing is that you have to have a geometrical consistencies. So, once you do this, I can actually draw the pink going straight all the way. Now, what happens to the white? So, white starts from here, goes up, it then goes down, then it goes up and on this side. What happens to the yellow one? So, yellow one goes down, yellow one goes up and yellow one goes down and connection is made. So, this is the configuration which will come. This configuration in no way can be transformed into already done configurations with 3 inputs. Okay. Yeah, there is no way it can be done, these are all different ones. So, I will draw this third one also. Now, let us look at the other option. So, I should exhaust all the possibilities. So, I had started from the top, I will still go this way, but I can go till top and then come back down. So, that is the first, so that I am exhausting, is going straight, this time I am putting it down. So, I get this configuration is, if I just simply swap it like this will turn out to be nothing but this one, is a straight line, you will have this now. This one is exactly what is being drawn here, this one. So, in fact, you can actually move from here to here and here to here, that is what it means. Okay. So, I have not still exhausted, let me see what more can be done if there are other possibilities. So, we have this. So, now when I want to draw it, I cannot go from here to bottom because this line is already occupied. So, this has to be this is already exhausted, two possibilities. So, I have to now start from here to the bottom. If I go to the bottom, I go to up, I go to bottom, oh, I ended up in the same configuration which is here. So, I have exhausted all possible configurations when the third connection is set up, and this what will be the scenario. Okay. So, let us move further and talk about the fourth one. So, the fourth configuration is this. So, I will now put all possible configurations which are possible. I will start from the bottom actually. So, I will try to set up the connection. So, once I set up with the bottom one, so there is no possibility of going straight, goes up, it should go straight as far as possible, straight it cannot, comes to bottom. Oh, I think I have already got this particular configuration, this is what is going to be there. In this case, this is the configuration which I have actually drawn. So, from here actually I can come to this configuration also. So, I should draw a path here. So, let us look at all other possibilities. In fact, this you have to swap input to output, then it will be exactly same. So, let us draw the other one. So, I had actually started from bottom, I went to the top, and first of all I went straight and then down, okay, because there was no other possibility, but I could have come to the bottom also. Let me try this out. If I come this way, this is the configuration which I will get from this switch. So, essentially to compare, I need to put this down actually. So, I will do this swap, but I need a straight line. So, yellow I will be actually picking up as a straight line. So, these two need to be swept. So, once doing it, this is a straight line. So, I will just do the swap action. So, it means this has to be yellow one. So, I put the yellow one after this swapping. So, what happens to the white one? So, white one comes from the bottom, it will go to the top, it comes to the bottom, then it goes to the top and out. And what happens to the pink one? So, pink one goes straight, comes down, and this I think if you just turn it around, so this will end up in this configuration. And this is same as this one. So, from here also I can reach there. So, you can go come here, you can come here. So, have I exhausted all the possibilities? I have actually, I was trying to connect from the bottom first. So, bottom I went straight the up and then straight and then down, going went up, came down. Two things have been done, but I have not started setting up the connection from the top here. So, let us do that and see what is going to happen. So, I have to exhaust all possibilities. So, this time now I am starting and setting up the connection from the top. So, if I start from the top, I have to go straight, and first attempt is trying to go straight, coming down. No, I think this one is already there. Oh, you cannot compare currently, because you have to at least take this node down. So, I will do the swap, this one as a swap. So, this one here, so I have to make yellow as a straight line. So, I have to do this. So, I will make the yellow as a straight line. So, once I do it, what happens to the white? So, white actually is coming from the top now, going to the top, remain going on to the top and then coming down. And what happens to the pink one? Pink one starts from the bottom, goes up, then goes down and then goes up and again. And if I turn it around, you end up in this configuration. You end up in the same configuration which has already been mapped. So, from top also I have seen. And now, have I exhausted all possibilities? I went straight and then went down, but I can go down from here also. Let us see what is going to happen in that case. So, I went straight, earlier I went straight, I have already exhausted that particular mechanism. So, I will go down now. So, I have to go up and I will come to this situation. Okay. Now, this is equivalent to what? So, I have to essentially now convert it. So, I want the two outputs wherever is being occupied has to be on the bottom, two inputs has to be at the bottom. So, I will do the swapping. Okay, and I need a straight line. So, I can either keep pink or I can keep yellow, both are fine. So, in this case I will keep pink one. So, in that case I will do this swap, I will do this swap. Okay. So, drawing it, let us see what I will get. Okay, I should draw a pink here because that is what I want. So, I will draw a pink as a straight thing. So, now you understand that actually I am twisting the switches, inputs and outputs everywhere, because I am not bothered, I am just doing it without explicitly stating. So, I have mentioned in the previous video that this actually can be done. So, let us do it with the what happens to the white one. So, white has gone up, this white will go down, there was no swap here. So, now white will go up, it will remain up and out. What happens to the yellow one? Yellow one starts from the bottom, goes to the up, remains on the up, and then goes to the down. Oh, this turns out to be this configuration if I do this swap, this turning. So, input is making output, output is being made input, you will end up in the same configuration which is there in the first one. Now, I have exhausted all possibilities for the 3 connection setup for this one. Okay. So, from this state you can only reach into these 2 possible states. Okay. From this you can reach to this and this, from this you can only reach here, from this you can only reach here. Okay. So, now we are left with this one, let us see what is going to come out. So, as usual I will start from the bottom, I will go up, down, up, and as usual for example for I want to compare, I would like this to be on the bottom side. So, let us do that. Then I need a straight line, which actually means I have to do this swap also. Once I do this, so the yellow is a straight line, so I am keeping it here. So, let us see what happens to the white. This goes from the bottom, goes to top, goes to the bottom, goes to the top and out. What happens to the pink one? Goes to the bottom, goes to the top, goes to the bottom. This is same as this one. Okay. So, from here you can actually reach here. So, there was only one possibility. If I set up the connection from the upper one, then what is going to happen? So, if I make from the upper one, there is no way I have to go in this fashion. I can twist it around, I will end up in the same configuration which will give me this. So, only state from here you can go is to this one, and when you set up the 4th connection, then what is going to happen? Okay. When you want to set up the 4th connection, then what is going to happen? In this case, from here you will be able to come. So, I will be drawing it here. On the bottom side I can actually write it down. You have a straight line, you have a pink one going this way, the yellow one, and of course, we have a blue one. This is what is going to come. Okay. And of course, if you start from here, this one, so the blue one will go straight, come down, go up, and this. and clearly these two are not equivalent. This is not equivalent to this, you actually can see. So, these two are not equivalent, you can no way you can convert from here to here whatever way you do, because these two inputs are terminating here, these two inputs are terminating here, while these two inputs are being forking out, these two inputs are also forking out. So, these two are different states, so they are non equivalent ones. So, from here there is only one possibility which can happen, which is this. And this is the last connection. So, this is a different one. Okay. So, none of these can be converted to that one whatever way you do. Okay. Of course, though it looks like this actually can be done, but you probably cannot do it, whatever, these two are different ones. Now, once I have this whole state diagram, now I have to talk about how come it is a wide sense non blocking switch. Now, you have to identify which particular state is a blocking state. In this case, if you want to set up connection, it will go through, if any input and output, there is first state, second one. So, once you set up any connection from any input to output, you can actually do, and you will end up in one of these states actually. But if you are in these states, you can set up a third connection. So, from this input I can connect to this, from this input, because these are not available. So, from this input I can connect as here as well as here, both are possible, okay. And both, if I do it, I will end up in the same state. Here I can connect from here to here as well as from here to here, I will end up in one of these two states, okay. I can similarly set up a connection from here to here or here to here, both actually are possible. If you want to go from here to here, you just go straight and this way, so you will end up in this state. If you connect from here to here, you will end up in this particular state, okay. But here is a problem. If I want to connect from here to here, it is actually not possible. So, let us try to see if we can actually do it or not. So, if I have connection as this, other connection as this, so this is 1, this is 4, so this there is 2, there is 3. So, 1 prime, 4 prime, 3 prime and 2 prime. I cannot, if I want to make a connection, only way the connection can be done is 2 can go up and down. So, I can only make a connection which is from 2 to 3 prime and 3 to 2 prime, while 2 to 2 prime and 3 to 3 prime is not possible. This one is a blocking state. Now, whenever I am going to set up a connection, so if you want to set up, for example, a second connection, I have many options actually. If I want to, for example, set up from this to this, it is okay. Okay. So, from this input I will never end up in this state, but if I start from here, I have two options by which this input can be connected to this output. I can either go to this or go to this. So, it is my operational algorithm which will tell that when you want to set up a connection from here to here, never go to this state, avoid it. So, this transition is not permitted. So, you have to go to this state, and from there you will be going to these states and then to, of course, this one, and you can come back in the same fashion. But there is still a problem. It is possible when I set up a second connection, it goes from here to here, I ended up in this state, which can go to this state, and from there I will be able to, if the connection is released, I may end up in this, which again becomes a blocking one. My switch should never actually enter into a blocking state. So, what I should do is I should restrict this particular movement in the backward direction, when a connection is dismantled. So, I need to even avoid this state. So, this is also a prohibitory transition. So, when the third connection is done, so if the connection is from this one to this one, I can actually do it using in this fashion. So, you end up in this, so I should not do that. Okay. I should instead use this other option, I should go to bottom and then up, and then of course one was going this way, let me just draw it. So, I will end up in this. So, this kind of configuration is not permitted. Instead, what I should do is, I should not use this configuration, I should instead go straight and bottom, and this will become this configuration. So, this is the way the third connection should be set up, and I should avoid going into this state. So, third, all kind of connections can be set up. So far I am not permitting these two transitions. So, you will never see blocking if you avoid from here to there and from here to here. So, these two transactions, if these are being avoided, your switch will operate as a wide sense non blocking switch, and this is how actually we prove that a 4 stage system with 2 binary blocks in each stage will be a wide sense non blocking switch.